Hello students, today we are going to study the differentiation. Okay, so first we will see the definition of the differentiation. Say let y is equals to f of x, okay, be a function and h be very small such that x plus h belongs to the domain of function given function. Okay, then the definition says that limit h tend to 0 f of x plus h minus f of x upon h. Okay, if exists is called the derivative of f of x is called derivatives of f of x. Okay, so mainly when we have to find out the derivative, we represent y is equals to f of x. So we say differentiating, we write differentiating with respect to x. Here x is the variable, so we can say that dy by dx, or else we represent f dash x, or this y we can represent as y dash. So y dash is represented as a first order derivative. The students may confuse with this, like y is equal to f of t. Over here, so t is the variable, so at that time we have to differentiate with respect to t, as t is the variable. So it will become dy by dt, or else we will find it f dash t, where t is the variable. So in this 11th and 12th grade, what type of functions we have to study? Okay, mainly, so y is equals to f of x. Okay, the function we have to study, say L I A T E. Okay, so L for we have to study log functions, I we have to study the inverse functions, for A we have to study the arithmetic functions, for T we have to study the that is trigonometric function, and for E we have to study the exponential functions. Okay, for log we can easily identify that log x, so y is equal to log x, y is equal to log t. For the inverse is related to the trigo, so sine inverse x, cos inverse x, tan inverse x, like that. Arithmetic is comes with the quadratic equation, normal, x plus 5, x plus 2, or x cube plus 2, x plus 3, that sort of arithmetic functions. Okay, trigonometric is that 6 ratio that you studied in 10th, that is sine x, cos x, tan x, cot x, sec x, and cosec x. And for the exponential special case, in exponential is comes under the e raised to x and a raised to x. So we have to find out the derivative of that function. So how to find out the derivative of the function? So first, this same formula is known as a first principle. Okay, so what we say, the derivative by the method of the first principle. So this is by the method of first principle of first principle. Okay, in that way, so we will find out the f dash x, that is derivative, is equals to limit h tend to 0, okay, f of x plus h minus f of x whole upon h. Okay, this also represents dy by dx. Okay, so we will find out, we will take the directly formula of these Liat functions. Okay, and the answer we can find out by this first principle method. Okay, so technically say, by for the example, okay, so y is equals to sin x. Okay, So if you want to find out the derivative of the sine function, the formula it says that y dash, or it represent as dy by dx is equals to cos x. So where it comes from? Okay, the derivative of sine x is cos x. So we have to solve this equation by substituting f of x is equals to sine x, and f of x plus h is equal to sine x plus h, and then we have to find out the answer that will come as a cos x. Okay, and that we will see in a next addition of the limits. Okay. So next, we will find out the derivatives of before that we will go by the Leibniz definition, which is very important for the 12th HSC, for the what we can say, the theorem which will come in the board exams. Okay, so Leibniz rule, okay, what the Leibniz rule says that, okay, so let y is equal to f of x, okay, be a function. Okay, so let del x be a small increment in x, and del y as y, the increment in x. Okay, so then we can say that limit del x tend to 0, okay, del y by del x, okay, is equals to dy by dx. Okay, so what is the difference between the del and that is, we can say, the dy by dx. Okay, when we write del y by del x, so it is very small increment. Okay, and this we considered as a small increment. Okay, so it will the technically difference, we can say that for dy by dx we can conclude at 0.5, or we can say 0.2, like that. But when del is very small, we will consider it will comes at 0.0001, 0.0005, like that. Okay, so this is the main difference, and these Leibniz rule we have to use in the theorem of the derivative. Okay, which we'll look in a next lecture. Okay, so next we will find out we will look at the formulas. Okay, formulas of the derivatives. Okay, so first of all we have to go by the derivative of the algebraic functions. So derivative, we have to look at the formula, and then we'll go for the rules. Okay, so derivatives of algebraic function. So for the we will start with the Liat, like that. Okay, inverse we will see afterwards. L, I, A, T, and E. Okay, so derivative for the log functions, that is called the log x. So we will conclude log and exponential. So derivatives for log and exponential. Okay, so this is y, and y is equal to f of x. So we found dy by dx and f dash x, okay, or f dash x. Okay, y is equal to, so dy by dx and f dash. So say y is equal to log x. So derivative of log x, 1 by x. Okay, next we have to go for the log. There is only one formula, and then next we have to go by the e raised to x. The derivative is e raised to x. Special formula, a raised to x. So a raised to x log a. Next we will go for the arithmetics. Okay, so arithmetics. So derivatives for arithmetics. So simply y and y dash. Okay, so for the y, okay, for the y, for the arithmetics, first we will take as a c, that is a constant, any constant number, or we can say the scalar number. So that will comes with the example for the 5, 10, 9. So it will comes derivatives as 0. Okay, next the best formula that we have to use everywhere, that x raised to n. The formula is n into x raised to n minus 1. Okay, x raised to n minus 1, x raised to n minus 1. Okay, next derivative of 1 by x is minus 1 upon x square, and derivative of root x is equals to 1 upon 2 root x. Okay, so log done, exponential done, arithmetic done. So inverse we will see afterwards, and we have to see only the trigo. Okay, so derivative of trigonometric functions. Next, derivatives of trigonometric functions. Trigo. Okay, so same y dash. Okay, so for sin x, cos x, tan x, sec x, cosec x, cot x. Derivative of sin x comes as a cos x. Derivative of cos x minus sin x. Derivative of tan x, sec square x. Derivative of sec x tan x. Derivative of cosec x minus cosec x cot x, and cot x is minus cosec square x. Over here we can observe that derivatives of co-ratio is always negative. Co-ratio which comes with the co. So co-ratio is always negative, otherwise all the derivatives are comes with a positive. And we can find out we can find out the formulas of this all by the first principle. Okay, this by the method of first principle. Okay, so we are studying the derivative in point of the 12th on the HSC. So when we will start for the 11, so we will do that thing also. Okay, so we will start with the derivatives basic. So this is the basic derivatives. Next we will come up with the rules. Okay, any formula is remaining? No. So next we will come with the rules, that is rules of derivative. That is called rules of derivatives. Okay, there are 4 rules. First one is addition rule, second subtraction, third product, and the fourth one is division, or we can say the quotient. Okay, this 3 and 4, the product and quotient rule, we will see in the next video. First we will consider on the, for this video we will consider on the addition and subtraction. For the first one, rule of addition. So say y, so we can say as if u is a function of f of x, okay, and v is a function of g of x. Okay, so u f of x, g v is g of x. So I want to clear it out, the function f of x or g of x, it most probably from the liat only, that is it may be a log, inverse, trigo, exponential and arithmetic. So if you want the addition, so if you want to do the addition, say y is equal to u plus v. So if you want to find out the differentiation, the differentiating with respect to x, So dy by dx is equal to du by dx plus dv by dx. Okay, same for the rule of the subtraction, same. Second, so rule for second, rule of subtraction, same. If we say y is equal to u, or we can directly by forget like this only, okay, very easily. So see y, so this will become, if when it is a u minus v, it will become minus. Okay, so it's a very simple rule of addition and subtraction. For that we will go by the example. Say u is defined as, say, e raised to x, okay, and v is defined as, you can say, tan x. So y is equals to u plus v means y is equal to e raised to x plus tan x. And if you want to find out the derivatives, so differentiating with respect to x, so dy by dx is equals to d by dx of e raised to x plus tan x. So this will become d by dx of e raised to x plus d by dx of tan x. Okay, so we will go for the formula. So check it out. For e raised to x, the derivative of e raised to x is e raised to x, and for derivative of tan x is sec square x. So derivative of e raised to x is e raised to x plus derivative of tan x sec square x. So this is your dy by dx. Okay, we are going by very basic manners, okay, and then we will go for the higher derivatives. Okay, so next we will take an example of this, okay, for addition and subtraction. First one, so y is equals to, okay, so y is equals to x raised to 4 by 3, okay, plus e raised to x minus sin x. Okay, we have to find out the derivative of this. So differentiating with respect to x, so dy by dx is equals to, say, d by dx of x raised to 4 by 3 plus e raised to x minus sin x. I am showing you each and every step, okay, for the board point of view. Okay, so this will become derivative of, we will take each and every term as we apply the rule of addition and subtraction. So derivative of x raised to 4 by 3 plus d by dx of e raised to x minus d by dx of sin x. Okay, so for x raised to 4 by 3, we have to use the formula for of d by dx of x raised to n, that is equals to n into x raised to n minus 1. Here your n is 4 by 3, so we substitute 4 by 3 x raised to 4 by 3 minus 1. So 4 by 3 minus 1, okay, sorry, 4 by 3 minus 1. Okay, so this will become cross multiply, so 4 minus 3, this will become 4 minus 3 upon 3, so this will become 1 by 3. Okay, so derivative of x raised to 4, we can say that n, that is 4 by 3 x raised to, so this will become 4 by 3 x raised to 1 by 3. Okay, directly we can use the formula that derivative of e raised to x minus derivative of sin x cos x. So this is your final answer for the addition is for e raised to x, and for sin x we can check out the formulas. Okay, sin x cos x, e raised to x is e raised to x. Okay, second we will go we will go for the second example. Okay, second example is y is equals to log x minus cosec x plus 5 raised to x minus 3 upon x raised to 3 by 2. X raised to 3 by 2. So over here, what you have to do? Okay, so each and every term, okay, so differentiating with respect to, before that we don't have to, we have to, okay, what we have to do, we have to make the equation very feasible to find out the derivatives, as we can directly find out the derivative of log x, so no issue. You have to directly formula. For cosec x we also have a derivative, so formula 5 raised to x we also have. I will explain it over here. So 1 upon, so what we have to do, minus 3 into this x raised to 3 by 3 by 2, it is in a denominator, so we have to take it into numerator. Okay, that will become minus 3 by 2. So it is very handy to find out the derivatives. Okay, as we can use the d by dx of derivative of x raised to n, that is n into x raised to n minus 1 over here for x raised to minus 3 by 2. Okay, so n is equal to minus 3 by 2, so this will become minus 3 by 2 x raised to minus 3 by 2 minus 1. So minus 3 by 2 minus 1 is equal to minus 3 minus 2, cross multiply by 2, this will become minus 5 by 2. So over here minus 3 by 2 x raised to minus 5 by 2. Okay, so this becomes a answer of this one. Okay, next 5 raised to x. So derivative of a raised to x, okay, the formula is a raised to x log a, where a is greater than 1. The condition is a is greater than 1. So when you will find out the index, okay, as the function of x, okay, this is the index is your function of x, and base is your number which is greater than 1. Why? Because log 1 the value is 0, so it is not applicable for 1 raised to x. Okay, so log 5, so as a is greater than 1, so 5 is also greater than 1, so we can apply d by dx of 5 raised to x is equals to 5 raised to x log 5. So we have find out the value of the two terms. Okay, so from here onwards, okay, we will say differentiating with respect to x. So dy by dx is equals to d by dx of, say we can say the log x, d by dx of log x minus d by dx of cosec x plus d by dx of 5 raised to x. You have to use bracket very wisely. Okay, then minus 3 into d by dx of x raised to minus 3 by 2. Okay, so x raised to minus 3 by 2. Okay, so this will become derivative of log x 1 by x minus derivative of cosec x minus cosec x cot x 5 raised to x log a. Okay, over here this is considered as a scalar multiple, that's 3 is a multiple with the functions. Okay, we consider 3 as a constant and we will put it out. So minus 3 into the derivative of x raised to minus 3 by 2, we will find out over here, that is minus 3 by 2 into x raised to minus 5 by 2. Okay, so the final answer is equals to 1 by x minus minus plus cosec x and cot x. Okay, plus 5 raised to log a is equal to minus minus plus 3 3s are 9 by 2 x raised to minus 5 by 2. Okay, before ending this video I will give you a short fundamental. Okay, that that short fundamental is about the constant. Okay, how we have to treat the constant with the variable. Okay, say we have to find out y is equal to say 12 cot x. You have to find out the derivative of this. So this 12, okay, this 12 is a constant. So at the time of find out the derivative, this we have to take out 12 into d by dx of cot x. Okay, so this will become 12 into derivative of cot x minus cosec square x. Okay, so for that 12 also, in next video I will explain in detail. You can use u into v rule, okay, and directly you can find out, you will get this answer, okay, by using the fundamental. Okay, but the students may confuse that this will also considered as a function, as a constant function, so can we use u into v? So you can use a u into v. That's a product rule that we have to study in the next video. Okay, so for this video, this is done. In next video we will study the product rule and the quotient rule in very detail. Okay, thank you so much. Please do like, share and subscribe. Thank you.